Well, hi there, boys and girls. I'd like to go ahead and give a little shout out today. I heard somebody talking about fifth period, flower girl, and I don't know. Anyway, so there you go. Got a little flower girl. I think it was Sabit, but I can't remember. Anyway, we're going to do bases other than E with some logarithmic review today, and this will be our last unit, or our last part of this unit. So I'm going to start with some basic log review. I want you to know that if we have y equals the log base a of x, this is a logarithmic equation. This can be rewritten as a to the y equals x. You should have learned this in pre-cal. That's a way of rewriting this. Okay, so let's just start with an example. Let's just say I wanted to find out the log base 3 of, we're going to erase that. That's a little messy. I apologize about that. We're going to have the log base 3 of 1/27th. And this is a question. You know, we have to answer this. We want to find out what the log base 3 of 1/27th is. So this means this has an answer. It's equal to, let's just call it x. So what I'm going to do is I'm going to convert this into an exponential statement to see if I can figure it out. So this means that 3 to the x power is equal to 1/27. Now one way to do this is see if we can figure out what 1/27th is as a power of 3. Now of course that's the same thing as 27 to the negative 1, and 27 can be written as 3 to the third power. So it's 3 to the third power to the negative 1, and you should know that when you are when you have a power to a power, you multiply those exponents. So that's 3 to the negative third power. So now that I have the same base, then I know that x equals negative 3. So that should be review for you, but it doesn't hurt to go over that. Let's do another example. Let's say I wanted to do the log base 9 of 1. And so again, I'm going to set it equal to something, and I'm going to convert it. You take this little guy right here, this is called the base, and you take it over here to the x power and you set it equal to 1. Now it's hard to write 9 as a power of 1 or 1 as a power of 9, but what can you take 9 to a power of to get 1 as the answer? Well, you should know that anything to the 0 power, that gives you 1. So my answer here, 9 to what power gives you 1, would have to be 0. So this answer would be 0. Alright, so let's go forward and do another example. What about something that doesn't work out very pretty? You're going to have to use like a calculator. So let's solve 3 to the 2x is equal to 75. And we want to solve this for x. Well, I cannot write 75 as a power of 3, so that's not going to help me. So what I'm going to do is I'm going to take the natural log of both sides. So I'm going to do an ln on this side and then an ln on the other side. Now we know from our properties of logarithms that means we can take this exponent down in front. So this is 2x times the natural log of 3 is equal to the natural log of 75. Then what I'm going to do is divide through by the natural log of 3 and then with the 2 to find my x. So x is going to equal the natural log of 75 divided by 2 natural log of 3. And I'm going to type that in my calculator right now. Natural log of 75 divided by, better put parentheses around this bottom or you're not going to get this right, 2 natural log of 3. My calculator says, well, it told me that same answer, that says that x is about equal to 1.965. You also could have done the natural log of 75 divided by the natural log of 9. I'm curious why that equals that. Does anyone know why those are equal? Okay, well let's just keep going with some more examples here. This is a lot, should be review, but doesn't hurt to see it. What if I have the log base 2 of x minus 3 equals 5? To solve this one, I'm going to exponentiate this, or I'm going to turn this into an exponential equation. So we take 2 to the 5th power equals x minus 3, and then 2 to the 5th power is 32. So we get that x is 35. You're going to practice some of this tomorrow in class. Alright, so let's get down to some derivative work now. Right now, we know that the derivative of the natural log of u is u prime over u. Okay, that's what we know. And we also know that the derivative of e to the u is e to the u times u prime. But what we do not know is, we do not know the derivative of something like 6 to the x. We know e to the x, and we don't know this answer. So I'm going to show you how to do this. So in other words, we have y equals 6 to the x. We would love to know what is y prime. So what I'm going to do is I'm going to take the natural log of both sides. So I'm going to have the natural log of y is equal to the natural log of 6 to the x. Then I'm going to use my properties of logarithms and bring the x down in front. So the natural log of y equals x times the natural log of 6. Now I'm going to take the derivative of both sides. Keep in mind, I'm trying to find y prime. The derivative of natural log of y is y prime over y. The derivative of x natural log of 6, keep in mind natural log of 6 is simply a constant. So when we take the derivative of a constant times x, it's just that constant. Now I'm trying to solve for y prime, so I'm going to multiply both sides by y. So this y is just going to move over here. And I get that y prime equals y times the natural log of 6. And this again is interesting. I get a derivative that is proportional to the original function. What was my original function? Well, it was 6 to the x. So this means that my derivative, y prime, is 6 to the x times the natural log of 6. Now let's see if we can make some connections to what we know before. When y was e to the x, y prime worked out to be e to the x. But there was also this hidden times the natural log of e. Why was this hidden? Because this equals 1, so we didn't even write it. So in other words, if your equation is y equals a to the x, where a is not e, then your derivative is going to be a to the x times the natural log of a. That's why we got this here. Okay, so let's do another example here. What about if I have y equals the log base 2 of x squared over x minus 1, and I wanted to find y prime? Well, I don't have a derivative of logarithm base 2, so I'm going to convert this into an exponential. This is why I did that review at the beginning. So 2 to the y equals x squared over x minus 1. And now I'm going to take the natural log of both sides. So the natural log of 2 to the y equals the natural log of x squared over x minus 1. I'm going to do some properties of logarithms here. Bring the y down. And then you can also separate this other side into the natural log of x squared minus the natural log of x minus 1 because of our properties of logarithms. Then divide through and you get natural log of x squared minus the natural log of x minus 1, and this is all divided by just a little constant, 1 over the natural log of 2. So to get y prime, we can just keep that constant there, 1 over the natural log of 2, and then we're going to do u prime over u, which you can simplify that to 2 over x, minus u prime over u. And that is your derivative. So the last thing that I want to do is show you a pretty tricky one, and that is, what if I have x to the sine x? What is y prime? Well, what you're going to do is do the natural log of both sides, go ahead and bring the sine x down because of my properties of logarithms, And now we're going to do the derivative of both sides. I'm going to ddx all of this. ddx that. So the derivative is y prime over y equals. Now I'm going to have to do the product rule. The first times the derivative of the second plus the second times the derivative of the first. And the last step is to take this y and bring it over here, keeping in mind that y was this original graph, x to the sine x power. So y prime equals sine x over x plus natural log of x cosine x, and all of this is going to be times my original y, which was x to the sine x. Last thing that I'm going to ask you, and I'm not going to do it for you, and if you could do this, can you find, if I have x to the x, can you find y prime? Don't know. That might be a good test question. Anyway, I will see you guys tomorrow.